addressed the design of the reactor, which consisted of a glass box with dimensions of 15, 14, and 8 centimeters. A set of 4 plates was used, 2 aluminum and 2 iron, with a thickness of 0.1 centimeters and dimensions of 2 by centimeters, maintaining a spacing between them of 2.5 centimeters. Regarding the preparation of the microplastic solution, we poured a standardized amount of microplastics into water and stirred it using a magnetic stirrer for 5 minutes to achieve a uniform solution. The initial concentration of each sample was 0.28 grams per liter. This concentration was calculated at convenience, but was based on previous studies that calculated the concentration of microplastics in the field in parts per million after a secondary process. For the microplastic removal process, we initially resorted to electrocoagulation, testing times of 30 and 60 minutes, and electrical potentials of 15 and 30 volts. Subsequently, we applied the flocculation technique in a machine programmed for 50 revolutions per minute for 10 minutes. After a settling period of 30 minutes, we were able to observe how the flocks settled to the bottom. Finally, to determine the efficiency of microplastic removal, we extracted a 100 milliliter sample from the center of the solution with a pipette and filtered it through paper with 2.5 nanometer pores. Subsequently, it was dried in an oven for 30 minutes at 50 degrees Celsius and finally weighed. The final concentration was calculated by subtracting the weight of the filter paper with treated MPs from the weight of the filter paper without MPs. It is relevant to mention that all procedures were replicated 3 times to ensure the accuracy and reliability of the data obtained. Results on the screen, we display a detailed table with the sizes of microplastics, determined through meticulous analysis using an electron microscope with a camera. As can be seen, the microplastics analyzed do not exceed 5 millimeters. In addition, we also present the specific details of the initial parameters of our experiment. The table shown clearly illustrates the average weight of the filter paper before capturing the microplastics, and in comparison, the average weight of the same filter paper after retaining the microplastics, taken from a sample that was not subjected to the treatment. Regarding the results obtained after electrocoagulation, a clear and directly proportional trend is observed in relation to the voltage, configuration, and treatment time. For example, at 60 minutes and 30 volts, the final concentration of microplastics decreased significantly compared to the 30 minutes and 15 volts setting. This phenomenon is reflected in the efficiency of the process, where an average efficiency greater than 95% was observed for the 60-minute treatment at 30 volts, contrasting with 61% for the 30-minute treatment at 15 volts. Interestingly, the efficiencies obtained for the configurations of 60 minutes at 15 volts and 30 minutes at 30 volts were similar, hovering around 85%.